0, 0, this one in the B. If it was 1 and 2, we should take it. Like we should make a cross also if it was like 1, 2, or anything else except 0.
I didn't understand.
Like in letter B, this the 0, 0. We should take it if it was another number like 1,
Yes,
2. We
yes,
should make it 1 times 2.
yes.
Okay.
Any number. It can work in any matrix, but it must be square matrix.
Okay, teacher. Thank you.
Yeah. Well, let's have now another example. What are the determinants of the following matrices? Let's solve B and C. In B here, we have an -2, 3, 0, 0. So the determinant here is -2 times 0 minus 3 times 0, which is 0 minus 0. So what is the determinant here?
0.
It is 0. Now let's find C. In C here, we have an 1, 2, 5, 0, 4, -1, 3, 6, 3. We have to copy the first two columns. 1, 1, 2, 5, 0, 4, -1. Then using the arrows. Minus the other one. Let's make it to the blue. Yeah, now let's solve the green one. 1 times 4 times 3 plus 0 times 6 times 5 plus 3 times 2 times 5 minus. Let's find now or multiply now the blue one. 5 times 4 times 3 plus -1 times 6 times 1 plus 3 times 2 times 0. Now, 1 times 4 times 3 is 12. 12 plus 0 plus 3 times 2, 6 plus 5, 30. 12 plus 5, it is 42. Minus. Let's find the blue one now. 20 minus 3 is 60. 60 minus or plus 6 plus 0, so it is 66. Then 42 minus 66, 4 minus 2 is 4, 6 minus 4 is 2, negative. So the determinant here is -24. Is it clear?
Yes, teacher.
Okay.
Teacher,
Yes, Maya.
in the first one, the last one, 3 times 2 times 5. Why 5? Isn't it supposed to be -1? The green line, the third one.
This is the third degree. Is it right?
Yeah,
You mean this one?
0, 4, -1.
Okay, sorry, I say that is 5. Okay, thank you.
Okay.
It's by mistake only. Here,
Yeah, no problem.
thank you. So here we have a -1. So it comes now like 12 plus 0. 3 times 2 is 6 minus 1 is negative, so it is 6 here. It's not 42. What I wrote before? I wrote as 42.
Yeah, 42.
So here it is a 6. So 6 minus 66, which is negative 60. Is it clear now?
Yes.
Okay.
Yes.
So by now we learn. Oh, sorry. We talked about what? We talked about what is the inverse matrix, or that's what is the square matrix? That any square matrix that has an inverse, multiplying the matrix with its inverse, you will get an identity matrix, or multiplying the matrix with its identity, you will get the same matrix. And after that, we say that not any matrix have an inverse. If you're multiplying the two matrices and you get an identity, so this will be an inverse matrix. If you will not get an identity, this will not be an inverse matrix. And we learned how can we find the determinant. The determinant only for the square matrix. There's no determinant for 3 by 2 or 4 by 7 matrix. The determinant only for the square matrix, for 2 by 2 and for 3 by 3. So for the square matrix, we have a determinant. Now, at the beginning of the lesson, here we say that also we can use the matrix to find the area of the triangle. This boy told me that neither height nor base is given, but still it's possible. If I give you this triangle and I ask you to find its area, you have to say, teacher, we know that if you want to find the area, we say half BH, or half AB, or half BC cosine A. 3 ways to find the area of the triangle, but neither the base, neither the height are given. How can I find the area of the triangle?
Shouldn't we have BC sine A?
I forget, is it sine of sorry. Okay, so, but here, neither the base, neither the height are given. I need to find the area of the triangle. What I have to do? In this lesson, we will learn how can also we use the matrices to find the area of the triangle.
Oh, it is benefit for our lessons in geometry.
Yeah, but this one here, yeah, but this thing, I give you the coordinate of the triangles, like this here, and you have to find the area of the triangle using the matrices.
Teacher, Ragad went out because her computer shut down. She
Okay.
has no battery. Okay.
I hear someone log out. Give me a sign. I don't know who is she. No. So here we can use the determinant. So that's why we learn how to find the determinant, because half of the absolute value of the determinant tell me about the area of the triangle. So you can use the determinant to find the areas of a polygons. Since all the polygons can be divided into triangles, all you need is a way to find the area of a triangle. So what is the area of the triangle? As I told you, we have vertices x1, y1, x2, y2, and x3, y3. To find the area, you have to say it is half the absolute value of determinant of A. So here I need a matrix. I need to write the matrix. This matrix, you have to find its determinant. Half of this determinant, you will find the area of the triangle. How can I write this matrix now? Look here, we have x1, y1, x2, y2, x3, y3. This is x1, y1, x2, y2, x3, y3. طب teacher, if I start with x3, no problem. But if you write x3, you must put an y3 beside it. Then, this is not a square matrix. To make it square, you need to put 1, 1, 1, 1 here. Then after that, this comes now as 3 by 3 matrix. Find its determinant, as we learned before. In this one, like this. Don't forget, you have to copy. Them here. It must passing through x2. This one here must be here. Then minus. After you find this determinant, take the absolute value for it. Half of the absolute value of the determinant will be the area of the triangle. Let's have now more examples.
X1 will be passing through y2 and 1, right? Okay.
Yes, yeah, but here because I didn't write it
Yeah.
correctly. Now look here. What is the area of the triangle with the given vertices? 1, 3, negative 3, 0, and 5, 0. We have this triangle. You have to find its area if you have this vertices. What we have to do? Make the matrix. 1, 3, negative 3, 0, 5, 0. Then put a 1, 1, 1. So I wrote now the matrix. Let's copy now the first two columns. Then after that, let's find the determinant. One times 0 times 1, it is 0. Plus 3 times 1 times 5 is 15. Plus 1 times negative 3 times 0, it is 0. Minus 5 times 0 times 1, 0. Plus 0 times 1 times 1, 0. Plus 1 times negative 3 times 3 is negative 9. So it is 15.
15 plus 9?
Plus 9, which is 20.
24.
So
Then
the area is 12?
the area will be half the absolute value of the 24. And the absolute value of the 24, since it is 24, half of the 24 is 12. So the area of the 12 of the triangle here is 12 square units. Is it clear?
Yes, teacher. Thank you.
Let's solve now another example. One, 3, 5, 8, and 9, negative 1. Then add 1, 1, 1. then its determinant will be copy the first two numbers here. 1, 3, 5, 8, 9, negative 1. Then let's find the determinant. One times 8 times 1 is 8. Plus 3 times 1 times 9 is 27. Plus 1 times 5 times negative 1 is negative 5. Minus the second one now. 9 times 8 is 72 plus 1, 72. Plus negative 1 plus 1 plus 1 is negative 1. 1 times 5 plus 3 is positive 15. Then 8 plus 27 is 35, minus 5, 30. Minus 72 minus 1, 71. 71 minus 15, 86. 30 minus 86, negative 56. So the determinant here for this matrix here is negative 56. Then the area is half the absolute value of negative 56. What is the absolute value of negative 56? 56 times half positive 28. Okay, this is will be now the area of the triangle, which is 28 square unit.
Is this the last lesson or still in lesson 3?
No, we are still lesson 3. Now, here now, I told you at the beginning of the lesson that if you multiply any matrix with its inverse, you will get an identity matrix. How can we find the inverse matrix? To find the inverse matrix, we will use the determinant. What does this mean? That means if I use the determinant, I can find the inverse of the matrix. If I find the inverse of a matrix and multiplying it by the origin matrix, the answer will be the identity matrix. Now, I told you also at the beginning that not all the matrices have an inverse. It must be a square matrix. And except although it is an square matrix, not all the square matrices have an inverse. How can I know? They told me here that if the determinant of a matrix equal to 0, this one we call it a singular matrix and there's no inverse for it. But if the determinant is not 0, to find the inverse, you will say 1 over the determinant of A times this matrix. Let's see now how can we find it. So as I told you, to find the inverse for the inverse matrix, I must have a square matrix, and for this square matrix, the determinant must be not equal to 0. If it's equal to 0, I call it a singular matrix and there's no inverse matrix for it. But if the determinant is not 0, there's an inverse matrix. What is the inverse matrix? I will repeat. The inverse matrix is a matrix. If you multiply this inverse matrix with an original matrix, you will get an identity matrix. So now we will see how can we find the inverse matrix. That's if I multiply it with A, with the origin one, I will get an identity matrix. What do you have to do now? Let's see this example here. Does this matrix have an inverse? The first step, I will look at it. Is it a square matrix? Yes. So it could be. The second step, I will find its determinant. If the determinant equal to 0, I will tell her, thank you so much. You are a singular matrix. There's no inverse for you. But if the determinant is not 0, I will tell her, yes, you have a determinant. You have an inverse, sorry. So let's find now the determinant. The determinant here is 3 by negative 3 minus 6 times negative 1. 3 times negative 3 is what? Negative 9. Negative 9 plus 6 is negative 3. Is negative 3 equal to 0?
No.
No. So, yes, you have an inverse. Then, to find an inverse matrix, you have to say 1 over the determinant of A times. Let's see now, what is this matrix? How can I write it? Now, in the previous one, we have an A, B, C, and D. To write this matrix, which is you have to put it here, what you have to do? You change A with D, you put D up and A down. And then you put the negative of B and the negative of C. Let's do it here. Here we have a negative 3, 6, negative 1, and 3.
So it will be 3, negative 1.
So look here. Let's repeat it here first, please. Here I have 3. Look here. Here I have 3 and negative and positive 3. I will change the order. What does it mean? I will put the negative 3 down and the positive 3 up. So for the first diagonal, I will change them up and down. For the second one, I will take the 6 as it is, but I will tell her, stop, I must make a change, something. Oh, I must change you. I will write the inverse of it. And for the number 1 also, I will write the inverse for it.
Teacher, it's already negative. It will be positive or
It's negative, sorry. Yes. I find. So here it's a negative 1. So I will bring this negative 1 here, and negative of negative 1 is positive, which is an inverse of negative 1, positive 1. After that, I will bring this matrix now. Positive 3, negative 6, positive 1, negative 3. Now this new matrix is now the determinant, we found it before. It's negative 3. Let's write it here now. Then 1 over negative 3 or negative 1 over 3. Let's multiply it now by each element, like the scalar multiplication. Negative 1 over 3 times 3 is negative 1. 1 over negative 3 times negative 6, positive 2. 1 times negative 1 over 3 is negative 1 over 3. And negative 3 times negative 1 over 3 is 1. This will be now an inverse matrix. Is it clear?
Yes.
Teacher, but what do you multiply? Like,
Negative
You
1
mean-
over 3.
okay.
I multiply negative 1 over 3 by each number
Oh,
or by each element here.
So can you repeat the last part?
Here? Okay. Now let's multiply negative 1 over 3 by 3. Negative 1 over 3 by 3. If you're multiplying them, you get negative 1. Then the scalar multiplication. Multiply negative 1 over 3, but now with negative 6. You will get a positive 2. That's it. Multiplying now 1 over negative 3 times 1, you will get the same number. And if multiplying this number by negative 3, you will get a positive 1. Now, what is, well, okay, we found this inverse matrix. Let's see now. This is not, I will not ask you to do it, but here we want to check. If we multiply this matrix, the origin one, okay, let's see now. I told you that multiplying an inverse matrix with its inverse, you will get identity matrix. Let's see if this is correct or no. Here we have a negative 3, 6, 1, negative 1, and 3. Let's multiply it now by negative 1, positive 2, negative 1 over 3, and 1. Negative, so the first row with the first column. Yeah, negative 3 times negative 1, 3. 6 times negative 3,
negative 18.
negative 2. Then negative 3 times 2, negative 6. 6 times 1 is positive 6. Multiplying now with the second row. Then the second row with the first column. Negative 1 times negative 1 is 1. 3 times negative 1 over 3 is minus 1. Then with the second row, negative 1 plus 2 is negative 2. And 3 times 1 is 3. Let's now simplify it. 3 times 2, 1, 0, 0, 1. So as you see here, if you're multiplying any matrix with its inverse, you will get an identity matrix.
Yes.
Is it clear?
Yes, teacher.
Yes.
Yes.
Okay. Now look here. In this got here, we have to see that if this matrix have an inverse or no, and if yes, what will be this inverse? Let's start with A now. How can I say if it have an inverse or no? By finding what?
The determinant.
Determinant of A. 4 times 2 minus 2 times 3. 4 times 2 is 8 minus 6, 2. So the determinant here is 2. Then A inverse will be 1 over the determinant. Then let's write our matrix. Let's see now. Here I have 4 and 2. Change the order. Then the opposite of 2 is negative 2, and the opposite of 3 is negative 3. Then what we have to do, Maya, here now? Here you have a number half. This half you have to multiply it with this matrix. What you have to do?
It will be 1.
Give the half, multiply the half by every
So
single
you have multiply the half by each element. Half by 2 is 1. Half by negative 2 is negative 1. Half by negative 3 is negative 3 over 2. And half by 4 is 2. So this will be now our, this will be now an A inverse. Now let's solve B. Oh, first, is it clear?
Teacher, now if we want to find it,
Yeah.
we will make 4, 2, 3, 2 times 1, negative 1, negative 3 over 2 and 2, right?
Yes, but this is not will be. I will not ask you to do it. But you just approve that if you multiply an inverse with its origin, you will get an identity matrix.
Okay.
Now, let's solve B. First, you have determinant of the matrix B. Yeah. 2 times negative 10 minus 5 times negative 4. 2 times negative 10 is what?
Negative
20 minus 5 times negative 4 is negative 20. So the determinant here is 0.
It is not
It's not an inverse matrix.
because it is 0.
So I will stop here and I will say that you are a singular matrix. Is it clear?
Yes.
Yes.
Yes.